A binary tree is a non-linear data structure in C in which each node is connected to two successor nodes, namely the root, left, and right. In the C programming language, binary trees are widely used concept. A tree's root node is the node at the top of its hierarchy. Parent node are the node that contains other subnodes. Through this course, we will understand what is binary tree application of binary tree along with its implementation. We will also understand the declaration and initialization with a hands-on demo of binary tree using a C programming language along with its advantages and disadvantages. So what are you waiting for? Let's get started right away. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
Now let's talk about what is binary tree. So it is a hierarchical data structure. As we have seen in earlier data structures like arrays, linked lists, stacks, and queues. All of these data structures were linear data structures. But when you talk about tree, is a hierarchical data structure. That means it can have one or more than one children. Doesn't have to be explicitly two children. But when you talk about binary tree, therein you can have at most two children. That means if this is the node and then it can have at most two children, or if this is a node, it can have either left child or the right child, or it can have no children at all. Okay. So this is a binary tree. And now this is known as the root of the tree. That means the first node is known as the root of the tree. And you cannot access elements or these nodes directly. Okay. So now this is the whole structure of a binary tree. Now there are some common traversals, right? How we can traverse through all these nodes. So one of the common traversal is pre-order, wherein you always, whenever you are on this node, you always print this node first. What is the value of this node? Then you go on to the left side and do the same. Then again you go on to the left side, then do the same. Print, go on the left side, print, go on the left side, and so on. Unless and until there is no left, then what you do is print that thing, okay? Then after that, you will go on the right side. So pre-order follows print first, then go on to the left, then go on to the right. Similarly, post is saying that whatever is you have, print it at the last. So go on the left, go on the right, print at last. And in order says left, print, and right. So these are all traversals. We will also see one by one how we can implement it, and how we will also see examples based on these traversals. Now let's talk about the applications. If you have seen the file hierarchy system, wherein we have the root folder, and inside that root folder we have subfolders like music, and we have bin, we have files, we have program files, and all those things, right? So it is a kind of a hierarchical data structures, right? And explicitly here we are not talking about binary tree but generalized tree. Now if you have binary tree, it has multiple variations, right? If you talk about this binary tree, so here you always have either the left child or the right child. When you talk about BST, the childs are inserted in the tree in such a way that on the left side it will be always less than the root, and on the right side it will be always greater than the root. So this is a variation. It is known as BST. So you have aerial tree wherein you don't exceed the height more than 2. So that is one more variation. Then we have red black trees. So these are all variations of binary tree.
Now let's talk about implementation of binary tree. So first let's talk about declaration and initialization of binary tree. So we have a structure over here, and in that structure we have 3 data members. One is data part, another is self-referencing pointer, that is left, and similarly the right. So our structure will look like something this. So this will be our data part, this will be our left, and this will be our So this is the structure. Now let's see how to insert values in a binary tree. So we have this insert function over here, and in that function we are passing in the head, or also known as the root node. We are passing in the value and the direction. Or would you want it to be on the left side, or do you want to be on the right side? So this direction is over here. Now we have created a structure, a temporary structure over here, that is temp tmp, and then we are allocating memory with the help of malloc function, and we are also calculating the size with the help of size of operator, and finally we are typecasting it to the structure, that is pt. Then what we are doing, we are inserting the values in this temporary variable, that is tmp, and we are inserting the value. Let's suppose the value is 5, so value 5 is inserted. Then what we are doing, we are updating our left all as well as our right pointer to null. This is null and this is null. Done. Now what we are doing, we are checking if the direction is left. That means if the direction is left, if we want to insert it on the left hand side, then what we will do, we'll say, okay, whatever is in the queue, let's suppose this was our root, and in that root we had 10, and this is null and this is null. Okay, this is our queue, as also known as the root. Now if we are saying that whatever is, obviously these will be having some addresses. Let's suppose this is 1000 and this is 2000. Now what we are saying that queues left, that means we are talking about this position because the direction is left, so we are inserting this on the left hand side. We are saying if direction is left, then whatever is in the temp, put that in that left side. Okay, so that 2000 goes into here. That means this is linked and this is how it looks now. Okay, now next time, let's suppose another time we call this function again, called it again. Let me just erase all these things. Now we don't have this as temp, this is 2000 and done. So we are calling it again. Now this time around, what we are doing, we are checking, okay, if root is there, this root should be there, and this is 2000, right? So value is, let's suppose we are right now trying to insert 50, and then the direction is right this time, okay? So we are creating a structure. Let's suppose this is our structure. And in that data part, obviously with the help of malloc, we are having this null, we'll be having this null, and this is null. And then what we are doing, we are inserting the value in this temp data part of temp, that is right now this is temp. Okay, and the data part, let's suppose we are inserting 50, which is the past, and we are checking if direction is left. No, it is not. Else whatever is in the queues right, that means whatever is in the queues right, please insert temp in that temp. Let's suppose this is 3000. Okay, so this will be 3000 and these are linked. Okay, so this is what happens over in this slide. So in the next slide, what we are doing, we are just creating another thing, right? We are creating a root over here, and then what we are saying that, okay, allocate memory to this root. So that means that root function that was earlier here, the root node that was earlier here, this root node. Okay, we are having this root node, and what we created this, and we allocated -1 in the data part. Okay, and then in the left and the right it will be null. Okay, so then we are inserting this. Okay, and we are saying that, okay, insert the value on this side, insert the value on this side. Then we are again calling it, but this time on the roots left. That means whatever was in the roots left, this time this becomes the root. Okay, this becomes the root. And then what we are doing, what we are inserting on the left hand side, we are inserting 5. In this case, it was here -1, then it was the roots left was 3. And then this became the root, and in this roots left we are inserting 5. Okay, because it's on the left hand side. Similarly, what we are doing, in roots right, please insert 7. So this is 7. We are inserting the 7, and also this statement is there, that means roots right, please insert 2. So our tree will look like something this, 3 5 7 2. So we have this -1, then we have 3 over here, the left hand side, 2 over here, then we have 5 over here and 7 over here. This is how our tree looks like. Now let's try to traverse through this tree. So we are having this function over here, and we are using recursion, and we are trying to calculate pre-order. And pre-order means first try to print the data, whatever is in there, then move to the left hand side, and then if there is no left, then move on to the right hand side. And this goes for same for each and every node. that is there. So let's suppose we have the same node that we earlier discussed about, the same tree, that is minus 1, 1 second, minus 1, 3, 5, 7, and 2. Minus 1, 3, 5, 7, and 2. So this is our tree. Now we are trying to find out the pre-order. Pre-order means, let's name these as 1, 2, and 3. Okay, or P, L, and F. Okay, P, L, and R. Okay, so P, L, and R. Okay, so now is our Q null? No, absolutely not, because Q will be having some address, right? And that is not null. So pre-order means print first. So minus 1 will be printed. So this statement is done. Then what we will do, we'll traverse to the left hand side, and this time this will be the root, and we are calling this function pre-order recursively again. So now this left part is also done, but this time around we are here. Now this is P, L, and R. Okay, now again we are over here, and the first statement is to print the data. Now data is 3, so this is printed. This statement is done. Now we go on to the left hand side and recursively call it. So this side is also done, but this time around this will be the root. This will be P, L, and R. Is our Q null? This time this is the Q. No, it is not. Print the data. That is 5. This statement is done. Now move on to the left side. Now again recursively we call this pre-order again, but this time around roots left, that is there, it is null. Now this is our root right now. So is Q null? Yes. Return. So it returned. So because we are not doing anything, so it will return automatically. Okay. Now what is left? The roots right. Again, it will be null. So is Q null? Yes, it is. Again, we are returning. Now all of these statements are done. Now where will we? Will traverse back, because everything is executed. We will return to the function which called it. So this time around, the left side is entire left side of this is done. Now we will traverse on the right hand side. So in the right hand side, if you can see, we have the 7 left. So we'll move on to the right hand side. So this will be called. And now this will be having the same thing, P, L, and R. So in this, we will first print the data, that is 7. Then we will check for left. Left is null, it will come back. Right is null, it will come back. Done. Then what we will do? We'll traverse back to this portion. Now right is also done. Now this is left. So what are the things that are there? P, L, and R. So print your data, that is this. Go on to the left, this is null. Go on to the right, this is null. Everything is done. Return to this and return, then finally return to the main function, because that is the driver function. Done. This is how your pre-order looks like. Okay. So for this particular tree, minus 1, 3, 7, and 2, we will get the output as minus 3, minus 1, 3, 5, 7, and 2. This is your pre-order traversal. Now, what about the post order? Post order is similar to what we have already seen, but this time we will be first traversing to the left, then right, then finally printing it. Post means we will postpone the printing statement. Pre means we are printing the first statement. The statement that is first is the printing statement. Okay. Now let's see how it will look like for the same tree. So 3 was here, 5 was over here, 7 was over here, and it was 2, I guess. Yes. So this time around root is this. So we have passed in the root, and is root null? No, absolutely not. So what are the statements left? That are L, R, and P. So now we are not printing over here, right? Go to the left hand side. We are going to the left hand side. The statement is executed. Again, L, R, and P. L, R, and P. Okay. So again, we've checked. Is our root null? No, absolutely not. So we'll go on to the left hand side. Again, left is there. Left, we call this left. Is root null? Obviously, there's 3 statements will be there. Is our root null? No, absolutely not. Go on to the left. Left, it has gone to the left. Now it returned because this is null. So Q is null, we return back. Go on to the right. It is null, we return back. Now finally print. So we are printing. The first element that will be printed is 5. Done. Now, after that, we are done with the printing statement. It will return. So it will go on to the right hand side. Now right hand side is this. Now again, what will happen? L, right, left, right, and print. So left, there's nothing, return. Right, there's nothing, return. And then finally print. Printing 7. So left, right is done for this root node, but the printing statement is left. So we'll directly go ahead and print it. Done. We'll return back. Now left, entire left portion of this root minus 1 is done, but still the right portion is left. So we move on to the right. We will write L, R, and P. So there is no left, return. There is no right, return. So both of these are done. And then finally print. Printing 2, and we are done. So we have done and we will return. Then finally, the last statement that is left is print. So we'll print -1 and then we will return to the main function. Done. This is how your post order looks like. So we will get the output as 5732 -1. Done. Now let's look at the in order. So in order is that go on to the left, print the data, go on to the right. So printing statement will be in between. So left, print and right. Okay. Same tree. -1, 3, 5, 7, and 2. Okay. So now how will we do it? So same stuff, right? So this time around we have said that if q is null, then return. Else we were putting if q is not equal to null. Okay. Now we have L, P, and R. So is Q null? Absolutely not. Go on to the right. Go on to the left. We went to the left, right? And we again called this function L, P, and R. So is Q null? No, absolutely not. Go on to the left. We went on to the left, P, and R. Go on to the left. Again, is Q null? No. Go on to the left. We went on to the left. So left is null. We will return. We return from here. So left is done. Then we will print it. Then we'll move on to the right. So right is null, we'll return. So both of these statements are done. We went here. So print 3. Then move on to the right. Right, we went to right, left, print, and right. So again, we went on to the right. So this statement is also done. So now we check for this. So left is null, we print it. Right is null, we return again. So left, right, print is done. So we return to this function. No statement is left because right is already covered. Now we go back to the main calling function. That was this, wherein -1 was the root. Again, now we are here. So we'll print it. -1 is printed. Then we move on to the right hand side. So L, P, and R. There is no left. Return, print it. And then there is no right. Return. Nothing will happen. So entire right is done. So this is done. Then finally, we are returning back to our main function. So this will be the output as 5, 3, 7, -1, and 2. Now let's see the implementation of the same in order traversal, pre-order, and post-order in code blocks, along with the insertion, how we insert the elements. So now if you can see that we have these header files over here, and then we have the structure, that is binary tree, wherein we have the left and the right and the data part. These are all the 3 data members. Then we have this insert function over here, which expects the arguments, 3 arguments. One is the root, then the value, then the character. That is either the left direction or on the right hand side. We want to insert the value. Then we have defined the structure, that is the temporary structure, wherein we allocate the memory with the help of malloc and calculate the size and then typecast it. Then we insert the value in the data part, and then we update our both left as well as right pointers to null. This is the insert function. And then based on either the character, if the character is or the direction is L, we'll go on to the left side. If it is right, we will move on to the right hand side. So this is your insert function. Now, if you look at the in order function, which is there, we have this q, that is our root. If it is null, then we will return, else we will print, which is the order. That in order, what will happen? First, we go on to the left, then print, and then right. So that is there. We are recursively calling in order left on the left hand side and on the right hand side. Same thing happens on the pre-order. If q is not equal to null, then we will go and print the data because we are talking about pre-order. So print the data, move on to the left, move on to the right, recursively calling pre-order on left and right hand side. Similarly, post order will prepone our print statement, that it will be the last statement that is there. We'll check if q is not equal to null, move on to the left, move on to the right, and then finally print the data. And then our main function, in this main function, we have defined the root node with the help of malloc function, and we are allocating memory and size of, we are calculating the size of bt, then typecasting it to the structure, that is bt. Then root's data is -1. Then we declare or initialize our tree, that is the -1 being the root. On the left hand side, it will be 3. On the right hand side, it will be 2. Then on the left hand side's left, it will be 5, which we have already seen in the implementation. And on the right hand side, it will be 7. Now we will be calculating the in order and printing out the elements, and then calculating the pre-order, in order, and finally the post order, and printing out all those orders. Okay, because if you observe carefully in all these pre-order, post-order functions, we have the print statement associated, so we don't need to worry about printing out the elements or having a separate function for printing out those elements. Now let's save this file and let's now try to run and build and run this code. As you can see that this is our in order. You can check it with the earlier implementations that we showed. So this is the output that is here, which is 5, 3, -1, 7, and 2 for in order. For pre-order, it is -1, 3, 5, and 2, and 7, because in pre-order you're printing the first. So -1 is the root, so that is why you're printing it. In order, you will go on to the left, then print. 5 is the left hand side's first element. The entire left, when entire left tree is traversed, the left part portion, therein you have the 5 at the end. Similarly, we postpone our print statement, so we move on to the left, and then on the right. So right, there is no element in the right, so we'll be printing the 5. So these are all in order, pre-order, and post-order traversals for the binary tree. So in this way, we understood how to declare and initialize our structure when we talk about binary tree. Then we defined what the insertion function, wherein we were inserting all the elements that is on the left hand side as well as on the right hand side. Then we used 3 traversal methods, right? And we implemented them as well. Those were pre-order, in order, and post order. Now let's talk about advantages and disadvantages of binary tree. If you talk about advantages, we can represent data with some relationship, right? So this is the root node, or this is the parent node, and this is the child node. So that relationship, parent-child relationship, is always there. And while you are inserting or searching an element or a node in a binary tree, it is much more efficient as compared to other data structures which we have seen. Now, if you talk about disadvantages, if you want to sort this binary tree, it is much more difficult, right? Because we can either go on the left side. This can be a tree. That means this is a left skew tree, or this can be the scenario wherein we have all the elements on the right side of the node. So this can be another scenario wherein we have this right skewed binary tree. So sorting is difficult and it is not much flexible, right? If you talk about this binary tree, we always have either the two children or one children or no children. There is no flexibility in terms of how you want to store it. Can we store another node on the with this root node? No, that is not the case, right? And we don't follow any restrictions like, okay, we always find this node. That is, if this is a root node, we always find an element which is less than this node on the left side or on the right side. That is of the greater element. So that flexibility is not there.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.